So after proof of work function, what we need to do next is to create function that checks if everything is right in our blockchain. By everything is right, I mean we will check two essential things. First thing is we're gonna check if each block in the blockchain has correct proof of work or not. Then second thing we're gonna check is that the previous hash of each block is equal to the hash of the previous block. By checking these two things, we can see our blockchain is valid. So let's start with defining a hash function. What this function does is it takes block as input and returns the SHA-256 cryptographic hash of the block. So this function takes argument as self and block. Then we will hash the block and we will do it like this. Encoded block equal to json.dumps function, which takes two arguments, block and sorted keys, which we will set equals to true. Then we will do the same as like we did in the hash operation. So add .encode function, which keeps the correct format as expected. And finally return the cryptographic hash of the block by using hashlib library, hashlib.SHA-256 function, which takes encoded block, which is already in right format, and then .hex digest to get the hexadecimal format like we did in the hash operation. Alright, so we have the function that gives the cryptographic hash of the block. Now we will make the final function eachchain valid that will return true if everything is right in our blockchain. That is, each block has a valid proof of work and previous hash of the block is equal to the hash of the previous block. So let's make the final function. Def eachchain valid, and this will take argument as self and the chain. Then we need to create a loop as we need to iterate over all the blocks in the chain. So we will create a while loop. And before that we need to initialize that variables of the loop. We need two variables here. First previous block, which we will initialize with the first block of the chain, so chain and index 0. And then second variable block index, which we will initialize with 1 as the index of first block will be 1. Now we will create the while loop. The condition will be block index less than length of chain. Then first we will check if the previous hash of the block is equal to the hash of the previous block. For that we will get the current block equal to chain and block index. While starting the loop, the block's index is 1. So we will get the first block after the Genesis block. Now let's do the check. If previous hash of the block is not equal to the hash of the previous block, here we use the hash function we created. If the condition is true, then we need to return false. That means the chain is not valid. And now second check is proof of each block is valid. For that first we will take previous proof and then we will take current proof, name it proof. Now we're gonna check operation between two proof if it starts with 4 leading zeros. For that I will just copy the hash operation line and paste it here and replace new proof with proof, which is the current proof, and let the previous proof as it is. Now let's do the check. If hash operation has its 4 characters different than 4 leading zeros, then in this case we will return false. Now let's update the previous block. Previous block now will be the current block, and also increment the block index by 1. And now if everything went alright inside the while loop, we will return true. That means our chain is valid. And this sums our first part, building the blockchain. In second part, mining the blockchain, we will start implementing our blockchain.